Morning, myself, Vaji Patil, the assistant department of chemistry, Malaysia Art Science and Southern. So we have seen now aldehyde and ketone, the nomenclature and how they are naming it. Further, we will study properties. Start the physical property of aldehyde and so physical property are such as we will see boiling point and the solubility of aldehyde and basically aldehyde and ketones are carbonyl compounds, what we have seen. And as I mentioned earlier, the carbonyl bond is polar in nature. The partial positive charge on the carbon due to the lower electronic carbon. This carbonyl group is polar in nature. Can be form ions, as you can see, as electron is shifted from this pi bond, the atom, because oxygen is more electronic as we hence the electron were shifted to oxygen and negative charge from the oxygen. Then so the compounds aldehyde and ketones are polar. So hence so the interaction in pure state by dipole-dipole interaction. In pure state, the aldehyde and ketones interacting as a dipole. So due to the polar nature, aldehyde and ketones are showing the higher boiling points and more soluble water than the other non-polar compounds compared to the molecule. Further, we will consider boiling point as a physical property, and if we compare the aldehyde similar molecular weight that of alkane and alcohol. So here if you see molecular weight of this alkane 72, similarly the there is a alcohol is molecular weight 74. So and then we'll compare the boiling point. Here we can see it is a 36 Celsius, whereas boiling point of this aldehyde is 72 degree. Then boiling point of alcohol is 118 degrees Celsius. That of this ketone, the similar molecular boiling point is 80. As the increase in the strength of the intramolecular forces increase the boiling point, we can see here you will see the alkane, then aldehyde and ketone, then alcohol. So the boiling point is increasing because in alcohol there is a more hydrogen bonding due to the intramolecular bonding. The boiling point is in case of this aldehyde and there is a dipole-dipole interaction, but to the not presence of the any functional these alkanes here not show dipole-dipole interaction or hydrogen bonding. Hence, boiling point of the alkane is compared to that of aldehyde and ketone, then boiling point of alcohols are more. In case of aldehyde and ketone, if you see the boiling point of the aldehyde is less, 76 degree, whereas in case of ketone it is 80, 80 degrees Celsius. This is because the dipole moment of this ketone more compared to the dipole aldehyde. The interaction uh, uh, dipole moment is in case of the second property we are seeing that solubility. So, solubility of aldehyde here we can uh, is more if compound R, the number of carbon atom in the compound is equal to or less than 5. If it is less than 5, the number of carbon atom, solubility of aldehyde is more as compared to the number of carbon atom increases, solubility of the aldehyde, the water, is decreasing. In case of this, here we have seen, so this is the water molecule and then this is the aldehyde molecule. Aldehyde molecule forming hydrogen bonding with the water molecule by this oxygen, with the help of this oxygen, because oxygen partially negative charge, this hydrogen of a water molecule partially positive, so hence interacting forming the hydrogen bonding. So we have seen two properties: boiling points, solubility. So we will going shortly summarize. So here we can see a molecular formula of aldehyde. Here formaldehyde, acetaldehyde, and then the number of carbon atom is increased. So if we see the boiling point, boiling point is negative one, then 59. As the number of carbon is increases, as I mentioned earlier, boiling point of this aldehyde is increasing. Whereas the effect on the solubility of the uh, aldehyde is decreases as the number of carbon atom. Here we can see formaldehyde is very soluble in the water, but if we go down, case of acetaldehyde is uh, well, and then if it's propanol, then very soluble, but after the pentanol, solubility decrease. Similarly, that of the ketones, acetones, boiling point is 56. As we see in butanol, it is a 79 degrees Celsius. So as number of carbon atom, the ketone is increases, then the boiling point is decreasing. decreasing. Similarly, the solubility of the ketone decreases as the number of carbon atom ketone. So these properties, basically the boiling point and the solubility of this aldehyde is ketone, is depend on the number of carbon atom present in it. As the carbon atom increases, boiling point increases, and the solubility of this compound is decreasing. We have seen these are the two chemical properties that are mainly important, aldehyde and ketone. And further study the synthesis method or separation method of aldehyde. So aldehyde are basically oxidized form of the primary alcohol. So the aldehyde obtained from the alcohol oxidation. Second method is the reduction of acetyl chloride. So by using the different reagent can reduce reagent can reduce the acetyl chloride aldehyde, and then the reduction of the esters. The reduction also we can synthesize aldehyde. Then nitrile reduction. So we will study this method step by step. Here we have shown the general formula of the reaction in which we have taken the primary alcohol. Primary alcohol is basically alcohol containing CH2OH group, known as a primary alcohol. So here the the arrow shows two ways reaction. The reaction is a reversible reaction. We'll see this arrow above and shows the O in the bracket. It indicates the reaction of oxidation, way of writing the oxidation reaction. So if we oxidize the primary alcohol, it will form this aldehyde. Oxidation of this primary alcohol form the carbonyl attached to the hydrogen atom. So this is aldehyde, as we have seen earlier. So aldehyde containing RH group. So from the primary alcohol oxidation form the aldehyde. Further, we will oxidize this aldehyde again, then hydride or hydrogen get substituted by OH, and this group of carboxylic acid group. Oxidation of aldehyde further forms the carboxylic acid, and if you'll see, will reduce this acid by hydrogen, then it will form aldehyde again, and the further reduction of this aldehyde gives the primary alcohol. So this is the reversible reaction. We can synthesize aldehyde from the alcohol, and then reversibly we can synthesize the alcohol from the aldehyde by oxidation reduction. So here the oxidizing agent we have used PCC. PCC means pyridium chlorochromate. So this is the reagent which we have used for the oxidation of primary alcohol. So here we is that, right, and in presence of the DCM, we can oxidize the primary alcohol to the aldehyde. The mechanism of the reaction we'll see later. See, one of the reaction is the oxidation of primary alcohol into the aldehyde we are doing in presence of PCC. Next reaction, the similar reaction, primary alcohol is converted to aldehyde and carboxylic. But here we have used strong oxidizing agent like H2Cr2O4. Presence of acetone at 35 degrees Celsius, the alcohol, primary alcohol is directly converted in carboxylic acid. So this strong oxidizing agent like KMnO4, presence of acid at some temperature. This symbol indicate the uh, thermal reaction. We have to provide the heat. So such reaction, there is no formation of the aldehyde. It directly convert alcohol to the acid. Cannot reach aldehyde. This is the strong oxidizing agent like this cannot use for this aldehyde. Next, next is the state reduction of the chloride, acid, acid chloride, in which the lithium aluminum hydride, tributyl hydride, the fusing agent we have used. Here we will acid group RCOOH, in which OH is replaced by the chloride. Hence, uh, known as the acid chloride. So, if the acid chloride is get reduced by using this aluminum hydride. So, from this, the hydride group replaces the Cl minus. Here, replacement of the Cl gives the formation of the aldehyde. Similarly, we have taken the example chloride is replaced by hydride and which gives the effective aldehyde. Here are some of the example of the aromatic acetyl chloride in which the ALH short from aluminum chloride used for the reduction of benzoyl chloride forms the expected benzyl date. Clearly, the isovinyl chloride reduction the uh, isovinyl aldehyde. Next, next chapter we will study about the synthesis methods of the ketones, and then we will study the chemical reaction of aldehyde and so this chapter we have studied the physical properties uh, in which we have studied boiling point and then stability of the aldehyde and ketone. Then we have studied synthesis methods of the aldehyde in which we have first seen we have synthesized primary aldehyde from the primary alcohol by using and then we have seen the reduction of the acetyl chloride and then by using the LH study